All right, so we have 1/2 mv squared is equal to negative 150. All right, so I'm multiplying 1/2 times the mass times the speed squared. If this is negative, that means one of these has to be negative. Well, 1/2 isn't negative, it's, otherwise it would be minus.
You're showing like if you use the negative 100.
Yeah, and it's also answering Brianna's question whether the k will always be positive. So that is a positive number there, so that's not going to contribute to the negative there. So which means that my mass is negative or speed squared is negative. Mass is the amount of matter inside you. So negative mass would mean you've got not only no mass, but you've given, it really doesn't have any meaning here. So mass is a positive number, and speed squared. How can speed squared be a negative number?
You're going backwards?
No, going backwards would just change the sign, but you're then squaring it. Negative 4 squared and 4 squared are the same thing. What squared will get you a negative number?
Nothing, right?
There actually is something mathematically.
I?
Rebecca?
I?
Yeah, the imaginary number. I don't know if you're familiar with the imaginary number. I is equal to the square root of negative 1. All right, I see a couple of nods here and a couple of blank looks. Anyway, that would be negative 16. So the only way that you could have a negative speed squared is if you have an imaginary speed, which definitely doesn't exist in classical physics, which is what we're doing. So there's no way for the kinetic energy to be negative. It should always be a positive number. I actually did it was either a 151 or a 251 test, I did something like that, where you would end up with a negative kinetic energy, and what I wanted them to recognize was this is an impossible problem. All right. Let's see. I'll keep those. All right. So now let's fill in some details here. Let's make this a a 4 kilogram mass. So if it's a 4 kilogram mass, how fast was it going before, at the beginning of the problem? What was its initial speed? I'm not asking for initial velocity because I did not give the information for that. But there is enough there to find the initial speed. How would you find it?
Do you divide 50 and 4?
Why would you do that?
It's just a guess.
I always think they're gonna multiply.
Why would you do that?
Just a guess.
Okay. What's the formula for kinetic energy again?
1/2
mv
mv
squared.
squared.
You know, a little less prep that time, but still. 1/2 mv squared is equal to 50, because I said it's equal to 50. So it's 1/2 times 4, v squared is equal to 50.
So we wouldn't be multiplying 450, we would be using the kinetic energy formula. And we're gonna be multiplying 1/2 times 4 times.
Yeah. So we multiply that 1/2 times 4, so we get 2 v squared is equal to 50.
Divide by 2.
Oh, sorry.
And then I heard somebody say square root.
Yeah.
So V is equal to 5. 5 what?
5 joules? No, sorry.
Meters per
Yeah.
second?
Yeah, it's speed. Joules and kilograms is what we started with. Those are both SI units, so we better have SI units, the International Standard Units at the end. So it's going 5 meters per second. So we could have divided by 4 and then multiplied by 2, so potentially you were right. Definitely not multiplying 4 times 50. So it starts out going 5 meters per second. Let's make this conservative force. Wait. So,
The weight works on
pardon?
it, the weight works on it.
Yeah, we're making the conservative force specifically weight. So is this object falling or going up in the air? If those are your only two choices.
Falling,
Why?
because things don't weigh up, I don't know.
No, I mean, that weight can still be acting down, but there's an object going up. And there is conservative work being done on it, once it left my hand.
Is it going up because the kinetic energy is positive, or is that unrelated?
Because kinetic energy is positive, kinetic energy is gonna be positive as long as we're dealing with reality and classical physics. All right, so let's take a look at this. How fast is it going at the end? We'll come back to this. Or come back to the question of whether it rises or falls. So if that's my kinetic energy at the end, equal to 1/2 times 4 times V squared. What is V?
$11.18 meters per second.
Same process as before, just we have 250 instead of 50. So, is it going up or down?
This looks like it's going down.
Why do you say it's going down?
Oh, no, actually, what was the number we was looking at first? 250?
It started at 50
Five.
joules, 5 meters per second, and it ends up at 250 joules of kinetic, 0.18 meters per second.
It's, don't worry about me, I'm not lost, but I'm kinda lost.
Apparently not the only one. All right, what do the numbers mean? What does V equals 5 meters per second mean?
It's moving at 5 meters per second,
Okay,
that's the speed,
all right. What about 11.18 meters per second?
that's its speed.
Okay. It starts out at 5 and ends up at 11.18. What does that mean is happening?
Yeah.
Speeding up,
Yes, so is the object going up in the air or falling?
falling,
Yes, it's getting faster. It's not great mysteries here. I mean, some of the math might be throwing you a bit and also sort of coming back from a seemingly long break here. But it's getting faster. So falling. Now I'm gonna take a look at those three work energy relationships over there and come up with the exact same conclusion. So if I have weight acting on the small object, which way does weight act on it? Yeah, by definition of down. All right, so weight is acting down. So I have an object here, I have weight acting down. That first energy, the work energy theorem, the total work is equal to the change in kinetic energy. What was the change in kinetic energy?
$200 joules.
There we go. Yep. Is that a positive or negative number?
Positive.
All right, therefore the work was positive or negative.
Positive.
So positive work means that the force was in the direction of movement. Since weight acts down, the movement had to be down. Keep misplacing the diaper, there it is. Let's take a look at the second one. The conservative work equals change in potential energy.
Where did the 200 come from again? Sorry.
Change, when you're finding change, it's final minus initial, K final minus K initial. My final kinetic energy was 250, minus my initial, which was 50. That's where it comes from. Okay. Thank you. Anyone else before I rush too fast?
Yeah, me. I don't know what we always talking about, sorry. That was my 6-year-old calling me, said she wants the after school program, so I missed it, what y'all was talking about.
The secrets of the universe. That's what you missed. Sorry. Recapping, the total work is equal to the change in kinetic energy. That's just by definition. And that's equal to 200 joules because we started at 50 and we went to 250.
Okay.
So my total work was a positive number. And work is positive if the force is in the direction of movement. So since weight acts downwards, the displacement would have been in the same direction, downwards.
So just because you took off I don't know why I just wanted to put my own thing on and write up the total work of 200. But, okay. I'll watch the video.
No doubt riveting. Your 6-year-old will love it.
Stand her either.
Alright. I want to take a look at the exact same question about which way is it going based upon the second equation. This one's a little bit more obscure, but I still want to at least show that you get the exact same place. And let's see, get rid of this. All right, so my conservative force is weight. What is the potential energy associated with weight?
Gravity.
The potential energy formula.
Oh.
MGH.
Yep. So I know that conservative work is equal to negative change in potential energy.
That's what U is then?
U is potential energy from the German. And actually, I think it is from the German. It could be from the Latin or the Greek word for potential. So that's, change is always final minus initial. And they got a negative in front, so that's just gonna flip it. So that's equal to U initial minus U final. I got MGH here, it's my formula for U, so I'm just gonna stick that in. So I got MGH initial minus MGH final.
a negative minus a negative is gonna be positive, but if there's a negative to start, does that make it negative again?
Oh, when you're looking over there, so we started at negative 200, so this is negative of,
Negative 400.
thank you, negative 400 minus negative 200. So that's negative 400 plus 200, which is negative 200, and then the negative in front makes the whole thing 200.
So in the formula, the negative is always there?
Yeah, the negative is always there.
Okay.
So the conservative work is the conservative force times displacement. We have weight that's acting downwards. If it's going in that direction, the direction of that force, this is a positive number. And the only way that that can be a positive number is if my initial height is bigger than my final height. So, yet one more piece of evidence that it's going downwards. And the other one is that my conservative work total is 200 joules, as was just done. And since that's a positive number, the displacement has to be in the direction of the conservative force, down. All right, so let's potentially drop back and do something, I'm hoping simpler. Get some of the blank looks off people's faces.
I have a question.
Have a good one,
Yes.
Ethan.
Thank you as well.
For the initial is, 200 and the final is 400, so in the.
Negative 200 and negative 400.
Right, so but if you flip that like negative 200 minus negative 400, it'd be positive 200.
Yes.
And then you add the negative, so it'd be negative 200.
The difference is you always do final minus initial. If you do negative 200 minus negative 400, you're doing initial minus final.
Okay, got it.
Yeah, we have the advantage of not worrying about directions, but the order does matter once you do subtraction. All right, so let's just start out with it's falling. Let's start at 50 meters above the ground. Let's give this a mass of, it doesn't matter, but let's give it 4 kilograms. Kilogram object is dropped. After it has fallen 30 meters. How fast is it going? This can be solved using the stuff from chapter 2. I don't want to use the chapter 2 stuff, I want to use the chapter 7 stuff. All right, so object is dropped. What does that mean? What can we pull from that?
It's speeding up.
Okay, it will speed up, I'll buy that. There's another piece of information related to speed.
Gravity is pulling on it? Well,
Yeah, I'm gonna nitpick that. Yes, I am. So, you wanna try it again?
I guess. The weight of it is pulling down?
I'll buy that one. Yeah, again, gravity, huge topic, it's just the gravitational force pulling on it.
Okay, the weight of it.
Yeah. All right, so we have weight pulling on it, yeah, that, I'll buy that also.
It starts from, I guess, speed 0 because you're dropping it.
Yes. That's implied in the term dropping is that the initial speed is 0. So the initial speed is 0 meters per second, or whatever distance over time unit you want to use. So what is the object's initial kinetic energy?
0.
Kinetic, as you all know so well, 1/2 mv squared. Really doesn't matter what the mass is, the speed is 0, so the whole thing is 0. So my initial kinetic energy, 0 joules.
Okay. Okay, so, pause. So, whenever you ask it, what's your initial, what did you ask?
What is the initial kinetic energy?
Okay,
If an object's not moving, kinetic energy is 0.
if it was, so, okay. Starting at 4, then your initial kinetic energy would be times 4, like all of that, but put 4 in that?
It depends on what you meant by that.
I don't know. Never mind.
If it's moving, then it's gonna be 1/2 times the mass, which is 4 kilograms, times whatever the speed is squared.
So right here, it'd be 1/2, cause we're looking for, what are we looking for now?
Oh, I thought you were gonna just,
No, because you already said that was 0.
okay. All right, so